Good afternoon, everyone. On this gloomy, cloudy, 50-degree December day. But it's a lot better than when it was the day back in the summer when it was 107, if any of you can remember that. I don't know if you can see that very well, but it is 100 degrees today here in central Kentucky. Well, anyway, today's video is kind of a video request. The user Wave Action 90210 or 90210 or however has emailed me probably last week, and of course I'm late getting back. I apologize for that also. College finals week, getting ready for the end of the semester and everything. It just kind of had to push everything out of the way. But anyway, Wave Action 90210's email reads, question on hard to start 4.9 liter 6. I came across a video you made about hesitation and startup fix. I have a 1994 F-150 also with a 4.9 liter 6. I have trouble with cold weather roughly below the 35 degrees Fahrenheit, where it gets increasingly harder and harder to start the colder it gets. It runs fine when started. The choke even works well, but the starting part is hard. Do you think the idle speed controller and the throttle position sensor you mentioned in the video have any effect on the hard starting? It runs smooth enough after started. Thanks. Well, I don't really think that the idle speed controller or idle air motor is really an issue. And I don't really think the throttle position sensor is an issue. I could be wrong. I will have to go back and get diagnostic information on that also. But what I think that there might be one of three other issues going on. Or actually two issues can kind of meld into one. But I think there's definitely something else going on. And I'm going to go ahead and show you how to check that. Maybe we might uncover something there. So we'll go ahead and get with that. Okay, the first thing I'm going to show you would be maybe to check the ECT, or engine coolant temperature sensor. Right here it is. It's located on the heater hose line. Of course, you can unplug it. And of course there's two leads here. One is a reference wire, which will carry a 5-volt reference, and the other one will carry a signal back to the PCM. And I have an old Ford EC4 book that I will show you some testing procedures also with. And I'll just go ahead and plug this in so I don't forget. Alright, and the next thing I'm going to do is show you some, I would check the fuel pressure. And somewhere on here, let me go in here and find it, there will be a test port on the fuel rail. Alright, I have found it. It is way in the back. But you can see it right here, and I'm going to put my finger on it. Right there is the test port. If you can get a fuel test gauge, it threads on there, and what this will do is will give you the pressure that the fuel pump is pushing, you might say. And of course I have the specifications here. These pages are all stuck together. Okay, fuel pressure. Key on, engine off, should be around 50 to 60 psi. And with the key on and the engine running, should be around 45 to 60 psi. Yeah, the pressure will probably drop a little bit due to the injectors cycling. But it should be within that range anyway. And I would probably say more like probably around 55 to 60. Don't quote me on that though. But I would believe almost that if it was like in the 50 psi range, you would almost have an issue then. And even with it running, if you have it, you know, with 45 psi, you may actually have an issue. then of course, yeah, these are wires for the, but that would be the first thing I would check. And if you have fuel pressure that is low, the next thing that I would do is I would check amperage on the fuel pump. See how many amps the fuel pump is drawing. If it's not drawing too many amps, but a low pressure, that would indicate something like a restriction, kind of like maybe a restricted fuel filter. But if we're drawing like a high number of amps, we would probably be looking at a fuel pump that would be bad. So we go over here, and I know that a 94 is different, and I probably won't be able to get it down. Alright, I have the fuel pump relay right here. Broke a tab off of it. Well, gives me something else to fix, I guess. Alright, so here are the connectors, and I have a diagram. Right here is a diagram of the connector. And if you notice, see if I can get the camera far enough back, you'll see that they're pretty close. This right here is where I'm questionable, because I could not find a diagram for a 94. So, I'm kind of, stuck, right there with what to do. So I don't know if the 94s use the same connector or not. I'm going to guess that they do. But anyway, so what I would do is look for wire number 37, which is a yellow wire that is hot at all times, and wire 238, which is dark green with a yellow tracer. And what you will do is you will get a multimeter set to amps, and you will take one lead, and you will connect to this connector, and you will connect the other lead to that connector. What will happen is the fuel pump will come on, and your multimeter should read the amps. The amperage probably should be around 7 amps, 8 amps, I think. Once again, I cannot find any specification anywhere that gives me amperage information. So I'm going to take a shot in the dark. Probably around 7 amps, maybe 8. But if you have higher amperage than that, I'm going to say it's your fuel pump could be going bad. So that would be, this lead right there to that lead right there. Just take one lead right there and one lead from your meter and place it in both, and you should be, and that will actually hot wire the fuel pump, and you'll get an amperage reading. I would probably be tempted to take, make a jumper wire from the battery and go to the inertia switch, because I saw, like on the 94s, where this actually tees off and goes into the PCM. But right there you see your dark green and yellow wire and your yellow wire. Those are the two that will make the fuel pump work, actually. Alright, so we are going to go ahead and get into my old book here. This is an old book right here. Yeah, 1992. Well, okay, so, like I said, I'm going to give you information on testing the coolant sensor. Let's see, controls, outputs, let me look, got it here, computer precautions, GM diagnostics, electrical circuits, sensors, inputs. That's where we're wanting to go. Alright. Ford, let's look here. Engine coolant temperature sensor. We go to page 89. Okay, 33, 98, 54, 67, 87. And we're on page 89, application Ford. So that's what it looks like. It says what it senses. The sensor is placed in the coolant jacket of the engine. Senses temperature of the coolant. How it works. How it fails. Yeah, that's the important part. The how it works part's not really important. If there is no problem with the wires and connectors, then the resistance element itself can fail open, close, or be sending an erroneous value to the computer. Which could be a possibility if you're saying you're having a hard start. Okay. So we're going to test it. With the engine operating at operating temperature, which that would be like 195 to 200 degrees, you should have 1/2 to 1 volt. Okay. I'm trying to give me a book. They're trying to give me some kind of value on if it's low. There should be a table here somewhere. Ah, here we go. Here we go. You take a multimeter. Okay. At 50 degrees, like it is today, you should have around 2.86 volts. Okay, so what you would do if you're going to test this. Wait. I said it wrong. Okay, I was on the wrong page. Pardon me. Okay, so on a 50 degree day, at 10 degrees Celsius, it should be around 3.46 volts. So, alright, so here we are at the engine, and here is the ECT. And you want to take, a needle or a pin or something and kind of back probe this connector. They make special pins for it, but, safety pins or any kind of straight pin will work in that case. But you'll want to take a meter and, ground it to the battery. And connect your other lead to your pin that you have here, which you would want to back probe the signal wire back to the PCM, and you should have 3.46 volts or something like that, because it's a 50 degree day. Anything more than that or less than that, it would be out of range. Okay, so let's go back here to our book, and we'll kind of like throw some ideas together. Bear with me for a moment. Okay, here I am back at the book again. And if it's having a hard time starting when it's cold, it could be thinking, it's a warmer temperature. When it's that case, you will have a lower voltage across. Which could also be, if you have if it thinks it's 104 degrees outside, then you have somewhere around, 2.23 volts in resistance. I will show you how to check the resistance also. To check the resistance, you probably can't see inside these connectors too well. It's kind of dark. Oh, there we go, yeah. Okay, you want to put one lead on, pretty much on one electrical contact in there, and the other lead on the other electrical contact. Set your multimeter to ohms, and you should get a reading. And also your resistance will vary depending on temperature. All right, so hopefully this video has been kind of a help. maybe it can be some kind of clue of, of an indication of where to start on your hard start situation. And like I said, we're either looking at, it could be an ECT problem or a fuel problem. And I'm less likely to think that it would be a fuel problem. I'm thinking more it would be the the ECT problem. But anyway, I can take some of these and some of these diagrams. If you need any help with more troubleshooting or anything, or if you want some copies of these diagrams that I have, or some more information, let me know and shoot me, an email, and I can go ahead and forward these to you. Maybe, like I said, if you have a 94, it's different. It has a power distribution box where the relays are located, so that's going to change some. So hopefully, one of these will definitely, find the problem with your hard start. So that's about it, so far. And if anyone else out there on YouTube has, a similar problem, maybe this video can help you also. But that's about it for today's video. And I hope that I've been a help, and I thank you for watching.